Volio bih da kažem dobro večer svima. Da, tak, živim u Beogradu već 2 godine i učim srpski 2 puta nedeljni sa tutorom. Baš mi sve se sviđa ovde. I jednog dana bih želeo da držim govor u srpskom, ali ne danas. Okay. And today we will speak in English, obviously. I hope I do catch like Serbian like very quickly, so I hope maybe next year I will be able to talk something. I'm Aleksandr. I'm a C++ consultant now, like for the past 3 years, already. I mainly like do stuff in concurrency and graphical application for the past decade, and by accident I also do some building stuff. And I have been an active contributor to Conan like before COVID, but then COVID happens, then war happens, like all this stuff. So like I do mostly different stuff. And recently I have been doing mostly Qt. And Qt like consulting around Qt and Conan, how it integrated as well. And also I'm technically contributed to Qt now because I got my small change merge, so it's very nice. And I'd like to start in this my story of tooling voice and all errors and problems and everything I had about C++ from a long time ago. When I just like started to work in C++, I came to the shop and C++ to me was like Visual Studio. Like there was no compiler, no editor, nothing. Like Visual Studio was the C++. And at the time at the company, like all dependencies, even if we had like this little text file on some file server somewhere with instructions how to download and build it. And each time you needed to like set up a workspace, you needed to go fetch it, like check what you actually need to do. And like usually, especially was the problem with Boost, because Boost using Boost build. And it's very peculiar like build system, which is kind of funny because like I'm right now in the chat group with the after of Boost build, so like we talk very frequently. But at the time it's very, very confusing because I didn't understand C++ tooling at all, like all this like different multi-threading stuff, libraries, like architectures, like what's going on. I just want to make like a program run, like I want a window, and that's it. And we had like a funny thing, like since we're using Visual Studio solution, we like have coded all this absolute paths to our dependencies in solution files. And because of that, we, for some historical reason, we used the diskd for this. So each time you need a new workspace, you need to make sure you have a diskd on the computer. And if you want to work from home, you need to make sure at home you have a diskd as well. So like it made sense at the time, but obviously it didn't quite work like after some time. And at some point, like at some place, we even made our own dependency manager, like reinventing the wheel, like in Python. It was very simple. It didn't have any like configurations and stuff. You couldn't like pick like maybe x86, which we used to do it at the time as well, or 64 or stuff like this. It was just like the same solutions with the same coded configurations, but without the need to fetch this arcane text file with very strange like instruction which I didn't understand. And quite honestly, I'm not sure I understand them fully yet today, like because it was built is kind of complex. And we were in luck around the time when we had this dependency manager, because we also wanted to do some programming for Linux. We mainly used Visual Studio and for Windows, obviously, but for Linux, we needed to like figure out a whole other like ecosystem, and we were complete newbies. We didn't have any expertise for that. But Conan joined JFrog, and Conan was great for us because it was kind of the same tool, but like better. And it was backed by a big company at the time. JFrog already was like a unicorn startup. And we decided to use Conan. And why Conan? Because, of course, it's a cross-platform solution. It works on different platforms. Back in the days, VC package was already released in 2016, but it was only Windows-only solution, so it didn't work for us. we wanted like something cross-platform. And other solutions was a par as well. Like, honestly, even today, I'm not sure like what was even there like at the time which could work for us. It's written in Python, which is very nice. Like, of course, a lot of people are saying like you shouldn't have like a programming language in your tools because then you start to do very nasty things with it, which is fair. But like maybe after listening to what I'm trying to tell you today, you will understand that it's kind of required. You want to do some programming for your tooling. Otherwise, you will not cover all the bases on different platforms as you need. And of course, it has binary caching, which was very controversial at the time. Like a lot of people were like, no, you need to like compile everything you use every time, like whole the world, because like binaries is the root of evil and stuff like this. But after many years, like almost a decade, you know that binary caching is the thing. We can't really do anything without it. Even VC package right now has binary caching. So yeah. And of course, after this is a point which we came to appreciate over time. Like we can actually package everything. Like we have like some CMake templates. It's a package now. Like we don't need to do like some bad virtual control with it. Like it's like separate repo. We have CMake templates or something else, and we just pull like with version with log file all of that nicety automatically. You don't need to think about it. It's very nice. We can specify per project like tooling. It's a huge thing because, for example, recent version, like the latest version of Meson, it can compile some AutoTools projects today. Maybe already it can after a few patches, but at some point when they released the latest version, it couldn't. And what could I do? Like I have like, for example, Arch Linux. Do I need to get like an older version onto my system? No, I don't really want it. Like, do I need to do some local shenanigans? Else says, why would I need to do it? In Conan, you can just pin some specific version of Meson. It will pull it automatically and build it for you. It will use it for these specific projects. So you don't need like a single version of Meson like for a whole tree. You can just fix it for the project which fail. And it happens sometimes, not often, but like over the years, over 10 years, it happens a few times, which is enough to be a problem to consider. And of course, you can specify the project configuration, which is like architecture, maybe different one, standard version, all of this. And it's a point which I can't appreciate also recently. Maybe you know, maybe not. In C++23, the standard broke unique pointer in some way. They made destructor constructor in unique pointer. And it's a problem for Qt, because Qt now can build in C++23 mod on the version we used at the point when we noticed the issue. But it's used internally. So with Conan, we just specify, okay, Qt will use C++20. And with careful consideration, with like doing like this with fingers that, okay, all is good. Qt works with our projects on C++23. Also, technically, it can be built with C++23. And of course, compatible binaries. Like, it's kind of a weird thing where you don't really want to have a lot of compatibility because compatibility issues happens. You always build on like the most strictest mod possible. You always want to make sure your binaries actually work. But also the times when you don't need to build them it feels very nice. Like when you can pull all your dependencies like in a minute, instead of like 10 minutes or maybe 20 minutes, maybe half an hour, even if you have like big dependencies. It's very nice. And recipe-wise, like Conan is very simple. Like it has what type specifics Python can provide us. Else dependencies are fine. Like we can specify build requirements. Conan has kind of a model, right? It has like settings, which is a global configuration, and per project, like options, which is a local configuration. And all these tools, they're necessary. Like they're really useful. You will want to use it like when you use Conan. And Conan obviously is not really perfect. For example, this is all the boilerplate I need to write for like small library with 2 maybe library files. Like actually it's not everything. Like I just cut it at some point because like you need like a whole list of things. And we really hope that common package specification will fix it for us. It's actually what common package specification trying to solve is this thing. So we would not need to write all this meta information for each package, so it could be used in a build system independent way. That's the whole point. Like, because if we could just use CMake throughout all our stack, it would be fine. But a lot of our dependencies, they are not CMake, and we can't really do anything with it, right? And additionally, of course, you have all this boilerplate function, which you technically don't need it in Conan. You can template all of it. Is not a problem. Like how to pull sources, how to describe your build. Like if you always do CMake, like it doesn't matter. Like it's CMake, configure, install, and test, and all of this. And what I said before, why I like Conan is in Python. When we use Qt, we do a lot of QML development, and they have this QML language server. And it's very nice. Also, for some reason, it starts to leak memory on my machine, and like Linux kills my VS Code from time to time, and I'm like, okay, fine, I'll take it. But to make our packages work with QML link, we now have these little functions to provide metadata in the packages, and we have QML packages, and it's very cool. I really, it was very unexpected feeling when you have like a C++ package manager and just works with everything. Like you can compose a multi-language project without problem. But of course, like it has a lot of lines of code. It's not the biggest recipe. It's like the most minimal example I had in our like production code base. Like it's very stupid. But we hope everything will get better this time. It gets. Like Conan team, they're amazing. They're like doing so much work like in short notice. Like during like a few years, like changed everything and for the better. Like these are not random changes. I forgot. During this talk, I'm using photos I did in Serbia during my stay here, like from all different places. This picture I took in Zlatibor in April. Like it's amazing place, like very cozy, like a lot of these mountain rivers. Like it's amazing to just walk around and stuff like this. And you have this like mist falling down on the hill, like covering all the cliffs. It's very nice. It's kind of how we felt when we just needed to like develop for Windows and Linux on desktop, and we were like, fine, we have this workstation. It's very great. Like we don't need to do anything like Conan. It just gets better each year, and we're like, okay, do you have like some nice cities for us? And we upgrade it. All is fine. But at some point, this little guy came in. I'm assuming most of you like should be aware of it. Like it's a Raspberry Pi. It's like small computer. It's not an embedded system. It's like it's a computer, just very small. It has operation systems and stuff like this, and it has a lot of peripherals, which our engineers use for our devices. But the issue, the main core of the issue is that it's an ARM system, and all the ones they were 32-bit ARM systems, which will later I will explain why it's especially a problem because just ARM is not enough. And this one is a Raspberry Zero. It's also like a but it's very, very restrictive. And also I forgot to tell you what I'm doing. Like, who am I? We are doing metrology devices. Like, for example, this is PXI Express. I believe it's a resistive model. Yeah, this is a resistive sensor programmable sensor model. And we have these like crates with a lot of such models. We do like whole systems to test electronics, like complex industrial electronics, like different things. And what we wanted to do with Raspberry to make these portable devices, like small pools to like generate some signal to check, because usually if you have like a big electronic system like a plane, you can just have one small box, because a plane is huge. You want like you want people in different places, and you can have the small remote boxes to like pass signal in different places. It will work. It's very nice to think. But the problem is we didn't know how to compile for ARM, right? And the problem is it's not really about how to compile our projects, because CMake is fairly easy to cross-compile. Like it's not a problem. But we had a lot of dependencies. Like even Qt probably is the most problematic one, to be honest. Like they did get better, but it's still the most problematic one. Almost all CMake projects, they're fine with cross-building, but the rest, like after tools, especially at the time when we tried it. It was like 6 years ago or something like this. Just didn't work. Like didn't work. What we thought had some like initially maybe we could try to compile on the P itself. Like why not? Like someone thought like when Apple moved to ARM processor for their stuff, someone decided to make build crates for this. So why not? Like what's the difference? Actually, no, it hits very very like hard. A lot of hit when you try to compile Qt, for example, and we managed to fix it with better heatsinks, but it still didn't work. Like after a few recompilations, file system just started to kill itself. Like is some segmentation, random segmentation fault, and it's only fixed if you like reinstall the whole system. And it's not because the CD card is bad. Like we had like the most expensive, the most like certified, the best CD cards like accessible to us. Like I had no idea. Like it didn't work. Okay, it was a bad idea. We could technically we could download like random binaries from of the toolchain and dependencies. For example, there are some Qt binaries built for Raspberry and stuff like this, like GCC of course, and maybe some else we could find. And we pray that everything will work for eternity. Like no one will stop updating anything, or maybe when we need to update something, everyone will magically update everything as well. It didn't work out as we expected. We couldn't figure out how to make like Qt binaries properly because there are some issues with graphical devices as well on different versions on Raspberry Pi, which is like a whole other story. We could like just figure it out and cross-build everything ourselves. We didn't. We did like a few weeks, like even I believe it was a month when we're like, okay, we just can't do it. Like it's very hard, very complex, so many issues. We don't have time. We need to ship product. Like go go go. And what we came with, we started to use Camel. No, you are laughing, but it's like the most. It was the most right decision, the right call at the time. Like we couldn't do better. Like and it was great. Camel, if you are not aware, it's like an emulator for hardware virtualization, effectively. So you can use it to call ARM instruction on your like x64 desktop, for example. And a better thing about Camel is that you can use it with Docker, right? There are some Docker images which embed Camel into themselves. For example, Balena libs, which we used for quite a long time. And what they do, they allow you to run Docker container on your like desktop, which would be a proper ARM operation system inside. Like everything is natively inside, but it's 10 times slower, like 10, at least 10 times slower, maybe 10 to 20. Yeah. And it was fine. No, it was not even fine. It was great because, okay, we can now just compile normally with Conan as we do on desktop. There's no reason difference. That's how we do like our CI in GitLab CI. Like that's it. That's all we need to compile for Raspberry. No additional things needed. Like build instructions the same for desktop. So we reuse everything. It's just an image which is different. And in image is the same thing like as we do for desktop as well. It's just the base image is like for Raspberry instead of Debian, for example. And 5 years ago, it was fine. Like 6 minutes is mostly like pulling binaries around, like not a problem. But there's a small problem with C++ is that when you add a lot of code over time, it starts to get very slowly. And there's additional problems that we mostly like write in QML. And QML then we try to compile to C++. And as more graphical code we add, it started to compile much more. Like with each project, it started to add like half an hour. So when it was 6 months ago, when we were at the point when our build started to take like 2 hours, we were like, yeah, no, it's not gonna work because we started to miss deadlines like this. We can't work with our engineers. Like when our engineers come, okay, we have this new feature and we need you to like make a release very quickly so we can ship it to India, to Indonesia or something. We are like, yeah, no, we can't do it like that now. We need to wait until it compiles. Yeah, it was sad. And this is only for your project. Like, remember, binary caching is a great thing, but like, if you don't have your binaries ready, you will wait like 17 hours, and it's just for dependencies. And you have toolchain, which is also we sometimes rebuild for different reasons when you need to update. And of course, we tried like common techniques to try to fasten it up, like precompile headers. CMake is very nice about it. We did a CMake into our CMake templates package, which we use with Conan. We added this fancy interface targets, to which we added all the headers. We have like separate target for standard headers, for Qt headers, for boost headers. And C++ standard headers we took from Stellar Group from GitHub, I think. They have like very nice tooling situation around there. And it was kind of effective. It speed up like 2 times because like kernel codes, like it's all very like the same, like, and we have a lot of this. So it was very noticeable. But only on ARM machine, like on desktops, there was zero effect. Like we didn't notice anything. I have no idea why. Okay. And of course we used Ccache. Mostly like just as an occasional speed up. Like you can't depend on it. You have no idea when like there will be cache invalidation. You can kind of like fiddle with it, try to make sure like something works, but in practice, like we never noticed that we can actively rely on Ccache to cache things for some reason. I have no idea. And at some point, we didn't notice because our builds are so long that Ccache broke. Like it did not, and no one noticed because like, okay, 2 hours, 2.5, who cares? But the change was because we built inside Conan cache for some different reasons. And at some point, Conan decided to, for each build directory, to make unique hash number on each build. And for Ccache, you don't want it. You want it to know where like the same sources are. So you need somehow to propagate this information to it. So you need this like additional arguments to make sure it kind of works, which is fine. And now we we will stop talking about that. I will talk about a bit different things, like 2 different things. Of course, like it's when we just started to work on Raspbian, we picked some version they released like like a Debian Buster, Raspbian Buster, and Buster, the same thing. With somehow modern GCC at the time, but like it quickly got outdated, and we of course wanted to make better GCC, to use better GCC on all the tools. And we went on a journey to try to compile GCC for all our stuff. And because we didn't want to cross-compile GCC, we compiled it inside a Camo container. And it took like 18 hours just for like one run. Like it's very slow. And the problem is not that it's very slow to compile GCC. It's very hard to configure it, the build for this specific situation we have. And what I told you before, that ARM 32 bits is a huge problem because there's a bug with Camo and Linux kernel, a recent one, where Camo tries to call file system operations on the host system. And host system is not 32-bit, it's 64. And this mismatch, everyone is like, okay, you're to blame, and no one does anything. Like everyone ignores it. They're like kernel developers, they're like, we don't care about this, it's not our problem. Camo is like, it's a kernel problem, it's not our problem. Yeah, but effectively in that, it's solved with this definition, file offset bits. I will show you how we propagate it inside our toolchain a little bit later. Then we had, of course, because to build modern GC, you need to build every dependency updated. You can use like all the dependency. Bintil for some reason also bugged in the latest version. I have no idea why. It just doesn't work. So you need to just move a little bit back. There's a funny bit with CMake. Of course, on the the same issue with Camo. Very old CMake on this Debian version. Effectively, Raspbian is Debian the same. You have CMake which was not built with this definition. Only after some point it was built with this definition. But the issue is we can't use this native CMake to build newer CMake because it doesn't have it. So what we did, we took some newer version from pip, which was installed with this definition. And it's a very big challenge because everyone kind of like start to not build for 32-bit anymore. And you kind of need to hunt for binaries a bit now. Everyone like deprecates them, so it's a little bit of a problem at the time. And after this, we can use this a little bit more modern CMake to build the latest CMake we want in the system, and all the other tools. But it was, for some reason, was mostly the issue with CMake, like Ninja, Meson, like no problems at all. I have no idea why. And at some point, when we were playing with it and trying to test how this modern GC works, everything stopped working. We couldn't deploy, and turned out that Qt kind of forgot to check that the like run-brick configuration works. Like it had very obvious bugs. It didn't work at all, and we didn't know at the time because we are not Qt experts. We just want to compile for Raspberry Man. We don't want to like be super experts in this, and we can't be like automatically. But they fix it after some time, so it's fine. And another thing, like you want to use RPasses when you build with shared libraries, and we want to build with shared libraries because we want to use shared libraries like for graphical drivers and stuff. And it's a little bit problematic. You need like not just to pass it like to CMake dependencies, to AutoTools dependencies to make sure everything works, but there's a little bit problem with how GCC is built, because it's not just like one-way build. It has like 3 stages, I believe, and it passes these variables in a very unintuitive way. And I will show how we solve it as well a little bit later. And of course, yes, each dependency for GCC and all your other system dependencies, they are like built with difference for some reason, not for some reason, but for build system. And Meson is very popular. In my experience with system dependencies, it's more popular than CMake. I have no idea why. And each of the tools, they have their own fancy like tricks and things which you can like toggle and stuff like this. You need to be very careful with this. And that's how we kind of handle our flags. For LD flags, we need to pass their paths. Like this one is, the right one is for CMake, to the left is for AutoTools, and you need to expand origin as well for GCC, but just for GCC. It's the only thing which breaks. And it took me like maybe a few builds to figure it out. And for flags, you need to define this definition to make sure that camel bug doesn't work. And we still want camel. And then we pass these flags to GC build like this. And yeah, it was also not very trivial. GC building is slightly hard, and you need to explicitly set that you build for this specific like target system. You can just assume it will pick up that, okay, I am on this x64, it will build for x64. No, it doesn't work like that for us, at least. Maybe for someone else. You need to specify it as a target. And okay, we build GC. Effectively, what we do, we just pack every shared library together with proper passes, and like as a Debian package, we just install them all together at some place, and everything just works, like with drivers, with all the things. Of course, we use the base system which we use on devices, and the reason why we can like just upgrade the system is because like these devices are not at our place anymore, and we can do it with it. So we, for some time, maybe like 5 years, we'll support the system, I guess. Okay, maybe we'll drop it. I have no idea. And of course, you want to debug, right? These small systems, you can't quite compile on them. We couldn't figure out cross-compilation at the time, but now we are smarter. But at first, what we did, we had like this remote connection setup where we put like from desktop, we had a development built of our application, and we connected remotely to our device, like hijacked all controls. It worked like for business logic, for like hardware issues, like almost everything. The only issue for which we needed debugging were all Qt bugs. Like not a single problem which we had with our devices was on our end. Like every single one which needed debugging on the device is Qt bugs. No, I'm not joking. Like it's very sad stuff, but it's getting better, especially now we're starting to contribute to it. Okay, so it's very simple. Probably some of you are aware of how to do it. You need a GC version compatible GDB server on the target device. Since we built like our own GC for our program, we need to, with this version, we need to compile a GDB server. You can build it like statically, so you can just relocate it trivially, so it's not a problem. And for that, yeah, we used our Camo image. Always like when cross-compilation for some reason falls, we fall back to Camo, and it's such a nice setup. Like you don't need to think about it. Like, okay, if trivial way doesn't work, you can do like a long way. And for small thing like GDB server, it doesn't matter. Like you don't recompile it like more often than like maybe 1 in 6 months, who knows. You need GDB multi-arch to compile for libraries form. And we actually do just Conan install with specific profiles for host and build. Host is what is a target, like Raspberry, and build is our system which builds. And we specify that we won't debug dependencies. And what it does, it doesn't compile our dependency because of obviously of Conan binary caching. It just pulls required like ARM binaries to our systems. Everything great. In Make you can build it, like maybe from the console or from the IDE, it doesn't matter. And whatever means you have, like you rsync everything on the target, you launch and connect through the IDE. Like on VS Code there's an extension, on CLion there's also some way. In Qt Creator, I believe there's this interface as well. It's very simple. And we just decided to like, because a colleague who did this investigation with Qt bugs, he just decided to use binaries for GC. We didn't want to build it. Like, what was the problem? And he found this repo. There all the instruction on how to build GC for like cross-compilation for Raspberry. So if you need your own version, you don't need to just download binaries if you don't trust them. You can build it. It's not a problem. And at this point, we realized, yeah, hey, why do we wait like 2 hours? Because like everything we need for cross-compilation is already there. Like it's not a problem. And we have all the expertise there. Like no reason to not try. And we did it. We made a Docker image for cross-compilation. It's effectively like we have our Camo host like system with sysroot from which like, because we have some different system dependencies and stuff like that, to make sure like everything is consistent, we just directly pick all the sysroot libraries from this. And we do like some fixed symlinks Python script, which I'm not quite sure it's how it's supposed to be, but it works like this, so I guess. And we download like our precompiled GC, of course, there as well. And our profiles for the build is the default native one, like whatever system we are on, it doesn't matter. And for host, for our target, for Raspberry, we specify like settings which we want. It's an ARM, it's some version, doesn't matter. And additionally, we need to pass all the information like on how to cross-compile for Conan to pass it to CMake. Like it looks a lot, but it's actually very simple. It's not really like something outrageous. Like it's the same thing like with origin, but without a double expansion of origin itself variable, because we don't plan to build GC. Like the whole strategy was, since we can't cross-build our own project, and maybe we can build some of our dependencies, we don't really need to like build everything. We could just, the bare minimum solution will be fine for us. Because if something doesn't work, doesn't build on our cross compilation image, you could just defer it to our Camo image, and that's it. And yeah, in GitLab CI script, it looks exactly the same, just different image. Like the same exact script for building, like nothing is different, like completely the same. That's how it looks like, how we invoke. It's not quite idiomatic, I would say, for Conan, but it's how it works for us. So you pass these profiles, you pass like some things to make sure it installs, and that's it. And this is my favorite picture. It's from the Gardosh Tower, like during evening, and the sky is very beautiful up there. And we had, yeah, effectively inside we have like 2 jobs. One manual when we want to defer to Camo, like if something breaks with our dependencies, we just, okay, click build all. And automatic one for cross build. Again, very simple, nothing to do, like, and our build came out with under 5 minutes, like from 2 hours to under 5 minutes. But of course, it's a bit like tricky one because it's when everything hits, like Zcash, like full saturation, all the stuff. So, but it's still, it's very like impressive, and we were so happy, like you can't even imagine. And yeah, and let's come to takeaways from this like a little bit ranty talk. It was absolutely the right call to use Camo when we like lacked the expertise. We couldn't do better. It doesn't matter. Like you want to do the job. Like who cares? Like even like until your project is like huge. Like we are not like hundreds of developers. We are like maybe 5, maybe less. Like 2, 3 people, depends. It doesn't matter. You want to make sure your app works on this target. And of course, our goal is not to build C++ in a perfect way. It doesn't matter. Like if it works, effectively. Like Conan is not perfect. Like there's a lot of issues because like you can execute some stuff during like building. Who cares? Like it's not C++ will never be like very secure in every aspect language. Like there's so many problems and no one to solve it. Like not a single person. Like there were so many bugs. And why? Because no one noticed them. Like no one is actually using as much things as we think. Like everyone like settles on some small version and just using it for years. So who cares? But at the same time, ecosystem actually evolves. Like things are improving very rapidly. Like to what we have today, we can like launch with Conan cross-compilation with the same exact instructions, which we couldn't do 5 years ago. Like Conan just didn't have it. And for tooling, I believe cross-compilation is like a holy grail. Like it's the idea of being able to build to literally every platform we can from our platform without like trying to dive into how to build this exact dependency. Like why do I need to be an expert in how Qt is built? Like it doesn't make sense. Like Qt should just automatically be built for like ARM or whatever. Who cares? So yeah, check out what's out there in the C++ ecosystem. Try to use it, but we refuse to try models. I will not comment on that one. And of course, something which works somehow for you is better than something which works perfectly for someone else, right? Like 6 years ago, like there were a lot of topic about like which is better, like Conan with the package, some like fetch content. It doesn't matter, use whatever works for you. Like if you only need for this specific thing, like with the package, there's no issues, no like tools you need. Okay, it's fine, like fetch content works, it works. Like just make sure like it's easy for me if I want to use like your dependency to use it in my own way, and that's it. Like don't be very restrictive. And on that note, I'm saying thank you. I'm Aleksandr. You can find me like on GitHub, on LinkedIn, on Discord, but maybe I'm not as active in there. Yeah. Thank you. Do you have any questions?
Yeah. So you use Conan for the fetching the dependencies. Did you ever consider Nix package manager? Because
No,
that's also a favor, like common solution to this problem. And why?
no, because Conan at the time, like we have our infrastructure set up where we have this Docker cluster and stuff like this. And at the time, like we decided to Conan purely on Artifactory because Artifactory is very easy to install. Like, we don't need to do anything at all, like for it to work for us. Like some backups and stuff like this, but that's it. And this community edition, we have seen that, okay, we can do all this binary caching without bothering with anything. And it was an argument as well at the time with VC package maintainers because they argued that, okay, we have binary caching as well. Like, what's the difference? You could do the same. And without this vendor lock-in, we have this Artifactory. And we are like, yeah, but like to use your binary caching, we need to do so many things we are not experts in. We don't want to do it. But with Artifactory, we just like Docker run or whatever, like in Docker's farm we use. And that's it. So yeah, for Conan, it's not like particular reason to use back then, but now we are very aware of its capabilities, of where it's going, and we are very confident that it will serve our needs as like C++ shop.
But so when you develop stuff, do you develop it on your host systems and compile there?
We do different things, like
Or in Docker?
we kind of have layers. We have dev machines. Of course, we compile on the local ones. We usually connect to devices like remotely, so we don't need to cross-compile our local environment. It's just a desktop application, effectively. And it just connect to this remote, like, we have some special interface, I believe. It's not an Ethernet, something else, I forgot. Yeah, some hardware one. And if we need to debug something on the device, we start this cross compilation debugging session, like, and usually it's again, if there's some problem with graphics, like, because graphics are the most painful, the most hard to track down. But if it's just business logic, like remote connection, it's okay. No one cares about it. Yeah.
But do you have any developers that develop on Macs? Because like you said, Mac is now ARM. So there's like, do you have that situation?
No, gladly no. No, if
Why gladly?
yeah. No, because like it's a lot of we already have with Linux Windows a lot of like Surface for we are a small team. We don't want to support like everything. And with Macs, with Conan, there were some problems. I'm not sure, like, because I don't use Mac, so I'm not sure what's the state of it now. But when I was active, there were a lot of problems because Mac was actively hostile to C++ like development ecosystem. Like it was closing all the hatches we Conan used at the time. So it's like, what's going on? I have no idea.
Okay. Because like from what I've noticed, cross-compiling and ARM support in libraries became much better when Mac switched to ARM because everybody realized it's a valid platform, not just the target platform for embedded developers.
It's still like you still need sysroot and stuff like this. So I don't believe it's not like a problem to cross compile just your application if it is simple, right? Like the whole problem is we have like big dependencies like Qt. Qt is the main culprit because the rest are fine. Like the rest you can run Conan install and they will be cross compiled automatically. It's like insane to me. Like I don't need to do anything. Everything is cross compiled. How amazing is it? Yeah.
Did you consider just using the ARM server? Now you have them.
Back in the time we didn't have it. Now we kind of don't care. Like everything is set, and because like this cross compilation setup is a byproduct of us just debugging on the device. Since we can debug, which requires cross compilation, like why not just have a job on the server? And if you have server like just on the common system, like why do we need another one? Like what's the point? We could just get like a better normal server if you want, like, because we still need to compile for like other normal systems.
Thank you for your wonderful talk. Afterwards, I have a few questions about the pictures. There are 2 or 3 pictures I'm not sure where they are taken. But let's leave that for later. So I just have a simple question. I'm really not an expert on all of this, but if you were are doing your project, and for some reason you want to switch from ARM to, let's say, some different core, let's go with RISC-V or whatever.
Okay.
Can you give us a simple overview what would need to change in your whole build system?
It will depend on how available cross-compilation tooling for this target system is, because I'm not familiar with development for it. I'm not sure, but if GC just works for it, you pretty much just need to change this part in the cross-compilation profile. Like you just need a different GC, differently compiled, and should be this fine. Should be that. No difference. I believe. Yeah.
Was the fix for 3246-bit issue with ARM?
Yeah.
You have to change that.
That's one when you compile, because we use Docker images using Camo, and that's the issue only there. And there you just need to make sure everything is built with this definition. Like with this definition, everything worked. I believe this was some problem with temp folder as well. You need to make like kind of in memory one, but it was written in the issue in Camo, but we haven't encountered why it was needed. The only thing which we only required was this. I believe if you would just build everything you need, like for you natively on this target, with this it should work. But I'm not sure if it's the same problem. It's just because it's a kind of common problem. I have seen, like, even in Conan issues, some people came up with Conan can compile CMake, for example, and I'm seeing this issue because there's some segmentation fault when it's trying to blow up. And I understand it's not a Conan issue, this specific. Even no one said anything about Camo, Docker, and that's it. And I already know it's this exact issue, and I was never wrong. There have been like at least 3 cases, I believe, like this. Yeah. So I just not sure. Maybe for risk, is it the same? I have no idea. Yeah.
Okay, thank you.
Okay, that's it.
Yeah.
Thanks, Aleksandr.
Hvala.